We should be live.
All right. Well, thank you. Good afternoon. I am Brent Palmer, the Manager of Measurement Technology for CRT Services, and just want to welcome everybody to this training seminar sessions podcast that we're putting on. Today's topic is going to be on FlowX Communications, and we're going to dive into FlowX, how it communicates via Modbus, some of its native protocol, how to configure it in FlowExpress, and also how to do a few other tricks and diagnostics functions inside of it. So welcome. If at any time you have any questions or anything, there is a chat button you can hit, or at the end I'll have a little Q&A section. You can unmute your microphone and ask a question if you have one. If not, please send us an email or get a hold of us, give us a call, and we'll answer any questions that we can. And of course, if we can't answer it, we'll make sure we can find somebody who can help you out and answer the right questions. So again, welcome. I hope everybody's doing well, everybody's safe, and we will get started. We'll go over our beginning slide here, which is welcoming you to CRT and our topic of FlowX Communications. So we'll go ahead and kill the whole PowerPoint presentation. And what we're going to go into first is we're going to go into FlowExpress. So I'm going to cancel out of this. FlowExpress is the configuration tool that we utilize to set up the FlowX, to put communications into it, and to create displays and the application itself. Today, we're just going to function on communications. Now, by default, the FlowX does not have communications assigned to specific ports. So the FlowX is a tag-based system, meaning that the information that we have is stored in tags with tag names. Now we speak Modbus and we speak some HTTP protocols doing web queries and things like that, but we have to assign tags to Modbus registers if we want to use Modbus. So what we've done is we've created an environment where you're able to take a tag and assign it to any type of Modbus data type that you would like, along with a register number for it, and you can create what we call sheets, whole templates of these registers or these tags put into Modbus registers. So another device that speaks Modbus can poll us and we'll respond back. And when we do this, we then have to assign it specifically to what ports we want to talk across. So with the FlowX, we have our Ethernet port, we have 2 serial ports, and we also have to determine whether we're going to be the master in the communications, where we're polling something, or in turn, it's polling us. And what I'll show first is I'm going to go into the professional mode and show you the templates that we've created, and also the manipulation that you can do to these templates to change the communications. So I'm going to go, I've already opened up an application that I've read from a device, and I'm going to go to the professional mode. And that is the only place where I can actually change the register addressing and so forth inside of the FlowX. So in the professional mode, we have a lot of tab functions down the bottom. And it's where we do our calculations. We set up our run calculations, our station calculations, our proving calculations. But it's also where we set up some default communications to look like devices, to create a Modbus tag list, or to pull other devices. So we have a couple tag lists which are developed by Spirit IT, ABB, and they come default with the US Liquids application. And they're called custom tags. And basically what it is, on the left, you'll see plus signs, and they're grouping of tags in registers, and it's broken down into run specific information. So as I go across, if I open up this one plus over here, I start off and I have what we call a query on the left-hand side in column A. Now a query is nothing more than a grouping of tags that are put together. So, and they follow some simplistic rules that we define in this sheet. So when I group something in query 1, I'm going to define its characteristics. I'm going to put the register size, the function codes that it can accept, and then I can add registers into it. And we have to follow some basic Modbus rules when we're doing this. If I'm a slave, then I can put an unlimited number of registers inside of a query. So I can create all these registers, and they're going to follow by this one set of rules. But if I'm polling something, then I'm bound by the maximum size that a Modbus master poll could be, which is 254 bytes. So I can only poll so many registers in one query, and then I have to create another query to get the remaining registers I may need. And typically when we do Modbus, we're also polling in groups. So I ask for a starting register, let's say in this case of 200, and I'll ask for 10 registers, and I'll get 10 consecutive registers back. But if I need registers 1,000, I can't say, well, in one poll, give me 200 and then also give me 1,000, starting at 1,000 for another 3. I have to create another poll or another query in the FlowX to poll register 1,000 for how many it wants. And then if I wanted to poll what's in the 2,000s, I have to create a third query and so on. So I'm going to show the difference between a slave sheet and a master sheet when we're actually setting something up to poll or when we're being polled by something. Now this ComTag list is a slave sheet. So it is something that's going to poll us, and we have definitions of these tags. And as an example, in query number 1, if we were to poll address register 200, I'm going to give you back what the system global. There is a status that's called, is there any alarm active? It's called alarms _ active, and it's a bit. So the data type that we've defined this is going to be a bit. So what that does is, if you poll that, I'm going to tell you whether there's any alarms active. And since it's a bit, I'm either going to give you a 1 or 0 back. So that query, when I look at the way the communication sheets are set up, that query is query number 1. So in our list here, going across, in query number 1, we're setting up that it's a device. Now, if I was polling something, and I'll show you a master where I'm polling something, but here I'm a slave, so I'm not worried about my interval, my timeout, my retries, or my sleep time. The type of register this is going to be is a 1, which is for coils or bits. The starting address is going to be 200. That's what I'm telling it in the address. And the length I'm saying of query 1 is going to be 50 registers. So I will go for 50. Oh, no. All right, hopefully I'm back.
You kind of froze out on us a little bit, Brent.
Yeah, I saw that. I'm good. I didn't want anybody to think I had a stroke. I'm all right, you know. So what we have is these Modbus rules. And again, so now I'm telling everything in query number 1, which is over ID 1, start at register 200. And for the next 50 registers, I'm going to allocate 50 registers of space. And everything that's there is going to be 1 byte. So the size is going to be 1 byte. And I will accept function codes for a single write of nothing. So I won't be able to do a single write to the device. I won't be able to accept multiple writes to the device, but I will be able to accept, if you ask me for a read, multiple reads. So when I send a Modbus message, if I send it to register 200 for 50 registers with a function code of 1, I'll send back the status of maybe 50 registers. It doesn't mean I have to put 50 registers here. I've just allocated the space for registers. So if I needed to add another register in this communication sheet, because it's written in Excel, I can simply copy down and say insert, and I'll put in some blank registers. And then I could actually even copy these registers and then start finding the registers that I want. And I'll start at register 236, 237, 238, and start building my register list up. Typically what we recommend is, if you need to add registers into a communication sheet, let us get with you and we'll help you build the communication sheet. So on these communication sheets, you'll see that we have this one that we've just went over, which is by default our Modbus tag list. We have another one where the registers are 16 bits in size. So we're not mixing in 32-bit registers, 64-bit registers. Everything is 16-bit. We also have developed some other registers where we look like, let's say, an OmniFlow computer. So again, we have that same query where query 1, we're saying starting at address 0 for a length of 600, everything's going to be 16 bits in size. And when I come down here, I'll start at register 1, address 1. Now again, I said for 600 registers, but I'm really, I haven't filled out all 600. You can see that I only have a few registers in here, but I could very quickly, if I wanted to create a custom register mapping, create my own register mapping by inserting and then starting create my own registers. So it's a way of you being able to manipulate any of the Modbus registers we have in here. So if I'm doing that, we can take a look at another one here, a bidirectional. And we'll go up top and you'll see in this one, we actually have some registers set up inside. So starting register 1, we're looking at the module 1. On the LU run sheet, there is a tag called indicated volume, IV B-tote forward current. And what that means is I'm looking at the indicated volume for the batch total in the forward direction, and I'm looking at that current totalizer. Now, what's nice about these Modbus mappings that we're doing is we can put this same tag over and over and over again and bring it back as different data types if we want to. Now, in this case, this is a long, which is an integer. It's a 32-bit integer. And if I look at my addressing here, you can see I started address 1, but my next address I use is 3. And the reason being is that a long inside the FlowX is 32 bits. And if we come back up here and we said, in everything in query 1, I said the size of them are 16. So that means I have to use 2 16-bit registers to take up and to put that whole 32-bit long in there. And if you ever want to find out all the different registers and so forth that we have in here, if you click on the cell for the data type, you'll see up top, there's a function called XD equals XD underscore long. Well, if I double click on the cell and I'll start deleting out the word long, XD will tell you all the different data types that we have. So as I look down, I can see that I have floats, I have bytes, I have characters. Oops, let me go back to this. So if I click on a float, let's say it's going to tell me that it's 32 bits, and it gives me the byte order that it's in. A long, it's telling me is a 32-bit signed integer. Now, what if I wanted just a 16-bit integer? Well, that would be a short. So I can keep on going down and look, and you see a short is a 16-bit signed integer. So that's how we can manipulate and change the data types inside here. I'm going to keep this as a long, and we can take any tag and make it any data type that we want. So again, I can reuse this tag. Now I know this tag normally inside of an Omni, if I'm looking for the batch in progress, meter 1, is going to be register 5101. So now if I scroll through, I told you we had these mapped up to use the same addressing as an Omni. It makes it easier to go into SCADA systems that are using Omnis. But when I look at 5101, it's that same tag, mod1, LU underscore run, IV, BTOTE, forward current. So you can use it over and over again, but this time, it's in query 10. And in query 10, I have a definition that says everything in query 10 are 32-bit registers. So up in query 1, that information is listed as a 16-bit register because there are some PLC systems and DCS systems that can't read 32-bit registers. They can only read 16-bit registers. So I'm able to put it into 2 16-bit registers to pass the information along, or I can put it in one 32-bit register, but it's all in the same communication template. And these communication templates are where we're going to go and we're going to assign those to the Ethernet or serial ports inside the FlowX. The last thing I'm going to show you while we're in professional mode is let's take a look at polling a device. So what I'll do is we'll look at, let's say, a micromotion. So now this sheet, this template that I have is actually it's a client, but it's a Modbus master / client. So now when I look at my queries, you'll see that on query number 2, I'm going to have an interval time. So every 100 milliseconds, I'm going to poll this query. I'm going to wait 40 milliseconds for it to reply. If I don't see a reply, I'll try 3 more times. And if I don't get a response, I'll wait 20 milliseconds and try again. And when I grab the information, I'm going to ask it for register 13 for one register, and I know it's going to be 16-bit in size, and I'm going to give it a function code 3. And then the next poll I'm going to do is I'm going to ask it for register 148, and I'm going to ask for 96 registers that are 16 bits in size, and so forth. So you can see in query 1, address 2, that's actually a function that I may write down to it. In query number 2, I'm going to start bringing back one bit of information, register 13, and I'm going to throw it into a tag called frequency output variable, and I'll save that in there. And then the next poll I do, I'm going to ask for 96 registers. So when I ask for those 96 registers, I'm going to stuff those in tags also. And that's all part of query 3. So if I wanted to create and poll something, let's say if I was polling, let's use an Omni. If I want to poll an Omni for information, I set up my different queries, 1, 2, 3, 4, depending on how the breakdown of addresses. So what I'm saying again in this one is, hey, every 100 milliseconds, pull the Omni for address 3843. I want 10 registers brought back, and they're going to be 16-bit in size. And I know that inside the Omni, that's the information that I'll be getting back. And then I want you to poll 4852 for 12, and then 5106. And I'm asking for 5106, 5107, but you'll see that I'm asking for 20 registers because I don't want to have to create multiple polls. I only need 5106 and 5107, but maybe I'll bring some information back later on. And then I'm also polling for 5119. So instead of having to poll for 5119, I'm asking for 5106 for 20 registers, which will also bring back all the way to 5126. So this 5119 that I really need, I don't need the registers in between. I'm going to bring them all back, and then I'll put 5119 into this new tag that I created. So it's a way that we can create these as polling or master sheets. And you'll hear we refer to them as sheets or templates. Now, how do I use them inside the FlowX? Well, when I go into the basic mode and I go to ports and devices, this is where I'm actually able to define what templates I want to put on what ports. So let's say I wanted to poll micromotion. Well, we have a template that already pulls back these micromotion registers we talked about here. So to assign that in the basic mode, I can put it either as, in the case of a 5700 head, I can right click on Ethernet. Now it doesn't matter which port. We really don't care about the port. There's 2 ports in the FlowX. I don't have to define what port it needs to go to because internally the FlowX will determine which port it needs to go to based upon the IP address you put in for it. But I'm going to right click on Ethernet. I'm going to say new. And then you'll see I can say, well, a micromotion or an ABB Coriolis or an E&H Coriolis. And these are where I'm the master and I'm going to be pulling information from one of those devices. So if I wanted to set up multiple devices, if I had 2 micromotions I wanted to pull, I would simply take that sheet, I would put it on, and I could call this micromotion number 1. And that's going to create a device ID of 4. I can put in the IP address here. And on the newer applications, we actually allow you to change the IP address also online with the device. And then if I had another micromotion to pull here, I could put another micromotion here and call this one micromotion 2. And now I have 2 different meters that I'm pulling, and I can use those within the application. I can then put an ABB Coriolis meter, let's say on serial, and I'll pull the ABB Coriolis meter. I don't have an IP to put in because it's a serial link. And then I've got a PLC polling me, so I'm going to tell it to look like an Omni version 20, and I can just put a name in here so I know what it is on the PLC. So in COM port 2, COM 1 is a master, COM 2 is acting as a slave to be able to serve up that communication sheet that we have that's called COM Omni version 20. And you can see that that's also here. So it's on Ethernet at the same time. What happens in the FlowX is it creates an instance, or it creates a copy of that sheet, and it uses it multiple times. So even though I only have 1 template for the micromotion, I've assigned it twice. So what it's going to do is it's going to create 2 instances of that communication template inside the FlowX, and each one of those is going to handle its own communications to a micromotion. The same way if I have multiple slave sheets listed on Ethernet, it's going to create a separate slave sheet for each instance that I have, or a sheet for each communication. And what that allows us to do is I can set this up where on this communication sheet, if I hit it at Modbus ID 2, let's say, if I change it to 2 and port 503, then I'll hit this version 20 sheet. But I may want to change on another one where, let's see, we'll add another one in there. So that's going to talk Modbus, but I want this same communication, and that's okay that I call it that name, but now I don't want it to talk Modbus TCP, encapsulated Modbus. I want it to talk RTU, and I want to be on port 2000. So what I've essentially done is I've created where I've got two of the same template. It's going to create an instance each one, and it's going to assign a little worker thread to handle the communication requests that come in. But one of them has to come through port 2000, maybe with a different Modbus ID, and I'm going to talk RTU over TCP as where the one that's coming across on device 3, which is coming in at 502, is going to talk encapsulated Modbus. So it's a way of creating multiple communication templates that are used within Ethernet and serial that allow the FlowX to look like other devices, or to create custom Modbus mapping, so you're not limited to having to use a standard template across the entire device. You can create large templates, you can create small templates, just a few registers. I don't need to create a template that's got access to 8,000 registers if the PLC is just going to pull me for 5 things: flow rate, temperature, pressure, density. So we can really stream these down. What I wanted to show you was an example of a system that's actually running where we have both slave and master sheets running, and kind of the diagnostics features in it. So what I'm going to do is I'm going to log into a FlowX that I have, which I've already done. So when I go into this FlowX, the first thing I can do is go to communications. You can see that I've created one that's pulling an Omni Flow computer. It's that template that we first looked at. I can change the IP address up here. I can change the Modbus ID. It's looking at the query statuses, and it's telling me that my communications is good. And then it's giving me the process information that I'm specifically asking for. I'm also pulling some remote I/O, but with the remote I/O, I actually am not doing, I don't have that set up properly. I don't have the right IP address to pull the remote I/O. If I knew what the IP address was, 10.221, which I don't think that's it, but it'll go out to device 221. It'll try to pull it. My watchdog statuses will actually change if it's right. And then I'll get my live information coming back here. The last one is I have it set up where this is a slave sheet. So I'm Modbus ID here, and if something's pulling me on a slave sheet, I'll actually answer back for that information. All those registers that we looked at, 5101, 5102, and so forth, are all being hosted up. And what I mean by hosted up is all of these registers that we put in the Omni version 20 are here. And that's that template that is live inside the Flow computer right now. So if I was to use a Modbus polar, we'll use simply Modbus TCP, and we'll connect to 10.1.10.200, port 502. Now I'm going to ask it for register 5101 for 10 registers. These are 32-bit integers. I'm going to ask it for a function code 3, because that's the way we set up the query too. And when I hit send, you'll see that I get my information back. And here's my results, the register results that I have in here. If I hit send again, I'll get the same thing back. Now, if I go to 7101, I know that there are floats inside the Flow computer. And I'll hit send. And now it'll give me the float information. And here's the hexadecimal, the bytes that it's giving back, and the actual results that I'm seeing. If I use in the FlowX our little diagnostics tool, which is underneath System, Diagnostics, and I go into Communications, the different communications that I have set up that Modbus client where I'm polling the Omni, another Modbus client where I'm polling the remote I/O, and then where I'm serving up, you see there's no IP address. This is where I'm actually serving up information. If I was to, let's say, click on all and hit start logging, what I'll see is the polls that are going out to the Omni and the responses back. So this is a nice little diagnostics tool that we have built in, and I'll stop that for a second. What I'm basically doing is the outgoing is red and the incoming is blue. So I'm asking Modbus ID 01. I'm giving it a function code 3. I'm saying OF03. And what does OF03 stand for? Well, if you saw some of my earlier videos, I explained a little bit about Modbus, that there's a great little calculator inside of Windows, and that I can go in Windows and hit Programmer, and that OF or 0F03, if I put that in the hexadecimal up here, and I hit 0F03, and look at the decimal, that's register 3843. And what am I asking for? I'm asking for 000A. So I'll clear that out. Click back on my hex. I really don't have to put the zeros in, so I'll put 0A. And I'm asking it for 10 registers. So 3843 for 10 registers, because that's what I've set my Modbus Communications master up for. And when I look at my little Omni poll that I'm doing over here, you'll see that I'm asking for 3843 in that query for 10 registers. So it's telling me I have good communications. Obviously, if I don't see anything back, then I don't have good communications. I may see the polls going out. Now, what about if something's polling me? Well, I can turn on a start logging, and I can already see that there's a device that's polling me. And it seems like it's asking kind of the same information over and over. The incoming is, and I'll stop this for a second, address ID 01, function code 3, and give me 1BDE. So what's 1BDE? I don't know. So I'll come down. I'll delete this out. 1BDE, register 7134. And it's asking me for one register. And here's another request coming in for 0029, 0027. So I'm getting pulled for different information, but there'll usually be a pattern in what's being asked for over and over again, because it's trying to efficiently keep on asking me for information. My settings for my COM ports, if I have a communication set up on my serial ports, I come into System, go to COM ports, and on COM port 1, this is where I can set my baud rate, my parity, my data bits, my stop bits, and whether it's 45 2-wire, and this can all be changed on the fly, because everything I do when I'm in the web browser is live within the FlowX. And again, if I'm polling something and I've set up my communication templates correctly, then I can change the IP addresses online with it. If they're older applications, then I have to pre-assign the IP addresses before I write them down. So I can do that in the basic mode by clicking on that communication sheet, let's say a micromotion, and assigning the IP address up here in IP addresses. And that's communications in a nutshell. If there's some more questions you have about communications, if there is something you want to go into in more detail on the communications, please get a hold of us, and we'll go over in a little bit greater detail with you on the Modbus communications. Oh, you know what I didn't show? There's a whole list. I think we'll do a separate topic on web queries and web services, because there's a way to pull the FlowX also without using Modbus and without setting up Modbus maps, by simply asking for information like snapshots or sysinfo. And we bring it back as XML information. So we can actually pull back the tags by creating tag queries using the tag names and ask for specific tag values back. but I'll create another session on doing that so we understand what we call web services. Are there any questions that I can answer? All right. Well, I appreciate everybody joining this afternoon, and I hope everybody has a good day. And we will be posting this up and posting some other videos up. We're going to do some smaller little training videos that aren't live here on different equipment. And again, if you have any topics that you want to go over, any questions, please don't hesitate to give us a call. And we look forward to talking with you next time.